Students, we are given this question to find the Laplace transform of delta of t negative a. Now this delta is actually what is called as the delta function. In fact, we call it as the Dirac Delta function. Now before we could proceed on with obtaining the solution for this question, it becomes imperative that we understand what the delta function is. Now the delta function is defined to be as delta of x to be equal to 0 for values of x which is actually not equal to 0. So the delta function takes the value 0 for all values of x which is not equal to 0, and it takes the value infinity for x is equal to 0. So this is a very important and pertinent definition for delta of x. So let me reiterate one more time. Delta of x takes the value 0 for all values of x not equal to 0, and it takes the value infinity when x is equal to 0. So at x is equal to 0, the function heads to infinity. Now if you were to integrate this from minus infinity to positive infinity, delta of x times dx, then it would have a unit area with the singularity being crossed at 0. So this is also a very important understanding. So now the all important question is, how do we get the delta function? Well, I can give you a simple example using step up and step down function. So let me just have this illustration. So I'm going to have this x and y axis. Now we are looking at a function which is going to be just existing around the origin, and it is going to be 0 elsewhere. Now let me just take a small value, say epsilon over on the left side, negative epsilon, and positive epsilon on the right side. Now we got a function exactly at negative epsilon. The function steps up and reaches a certain value, and then it steps down. Now the width of this function is going to be 2 epsilon, and in order for the area to be equal to 1, the value attained here, the height attained here, should be 1 over 2 epsilon. So from this step up and step down function, I'm going to obtain the delta function. So the question now comes is, how do I represent this by means of a function? So I'm going to write this as delta suffix epsilon of x. Now clearly, if you were to see the graph at negative epsilon, the function steps up. So I'm going to have u with the suffix negative epsilon of x, and at epsilon it steps down. So this is going to be u suffix epsilon of x. So this is going to be a representation for this step up and step down function. Now from here, if I want to write the delta function, the delta function can be written as delta of x is equal to limit epsilon tending to 0 of delta epsilon of x. So this is how we get the delta function. Let me show you one important property or characteristics of a delta function. Now if we were to have an integration minus infinity to infinity, say f of x with the delta function delta of x negative a, and with the differential operator dx, then clearly we know that delta of x minus a would become 0 when x minus a is equal to 0. So having known that particular fact, the delta function becomes 0 when x minus a becomes equal to 0. That would mean it doesn't matter what the value that the function f of x takes. So I can rewrite this as integral minus infinity to infinity f of a times delta of x negative a times dx. Now we got f of a, and we can take that f of a out. So that's exactly what I'm going to do. So let me just place f of a here, followed by integral negative infinity to infinity delta of x minus a times dx. Now clearly we know from the definition the area for this is equal to 1. So that would mean that we got this to be equal to f of a. So this is a very important property that would be used in the field of engineering. Students, let us now work out the question. We are expected to find the Laplace transform of delta of t negative a. Now from the definition I already mentioned, delta of t negative a can be defined in the following manner, that the function takes the value 0 if t is not equal to a, and it takes the value infinity when t is equal to a. So having defined this, because this follows from the original definition of delta function. So now from the definition of Laplace we can rewrite this to be as integral 0 to infinity e raised to the power of negative st followed by delta of t negative a times dt. Now we are very much bothered that for t minus a equal to 0, this becomes equal to 0. So we don't want that. In other words, it doesn't matter what this value takes when t minus a is not equal to 0. Because if t minus a is equal to 0, this delta function becomes equal to 0, and that is when we get the issue. So having stated that, I can rewrite this as integral 0 to infinity e raised to the power of negative s times a times delta of t negative a times dt. Now this can be further rewritten as e raised to the power negative s times a integral 0 to infinity delta of t negative a times dt. Now we know this area, that's going to be equal to 1, so this would mean e raised to the power negative s times a of 1, which is equal to e raised to the power negative s times a. So this is the solution. So though the integral appears to be complex, yet the solution is easily achieved from the definition of delta function. Thank you, students.